91 or 115, something like this. So what is this? This is numbers. These are numbers. But it gives you a little meaning about it. You can do something or many things in here. You can have a graph. You can just see mean, median, descriptive statistics. Because it is a single variable. We call the single variable as univariate data. Uni. Because it has only one variable. Like if I have sales, I have a data for sales. And you can have year also. Because you need to have year from 2020 onwards, 2020 to 2025, you have a data set. It is a single variable. So it is sales. It is called as a univariate data. If you have the data for sales and advertisement expenditure, there are two variables here. We call as bivariate or multivariate data if it more than two. So we are generalizing it. So we can do many analysis using the single variable itself. So that we will be seeing today. I'll take you there. So moving back to our presentation. Yes, this data analysis, it tells, the data actually tells us what is happening. And these are called as raw facts. We have many tools which is traditionally used. Simple Excel. We say it's simple Excel, but using Excel or excelling yourself in Excel is very important. There are really very good tools in Excel itself. Then we can use SPSS, R, Python, Tableau, Power BI, etc. for this data analysis. And what is this data? What is the question? That when I gave you few numbers, you can see something. What is this? Oh, what are these numbers? What had happened in future? Because you're having a data set in front of you, some 1 to 5 data set you're having in front of you, some 77, 82, 99, something you're having. So what are these? These are some data which is already available. So what happened in this data? What did it do? So this is data analysis. We are going to analyze the data. That is data analysis. Next. So what is the traditional data analysis construct of, what is it? This is what we did all these years. So traditionally, you analyze the data. You collect the data. Then you have to manually clean it. Then you analyze it. You interpret the data. And finally, you come to a conclusion. You decide on what is happening. What you have done after data collection or based on your analysis. Interpretation, you finally come to a conclusion. So these are, when you collect data, we already have primary and secondary data. Within that, we have this time series data, cross-section data, and pool data. Before I go to the data set, I thought I'll just give a slight glance about this. You know what is time series data? Data collected over a period of time and arranged in chronological order. And the time interval must be equal. So if I have data, just now I said no, for sales. Sales data I have 2020, 2021, 22, 23 and 24. Assuming I have data. So this is every year, yearly data, and it has equal intervals. Right? This is time series data. So there's a beauty about time series data. Time series data can be yearly, monthly, quarterly, half-yearly, decadal data, 5 years data, industrial data. It can be seconds data, minutes data, daily data, weekly data. So all these are time series data. Like when we speak about daily data, it is stock prices, weather report. Weekly data, we have monthly being economic, we can say money supply. Monthly data, unemployment rate is there. Even gold, silver prices, we get even monthly data in RBA. Quarterly data, GDP. And annual data, most of the data which we collect is annual. If I have time, I'll go to website and show you. I think most of you know about this. But anyway, I'll just show you what are the different types of data there. And decadal data, as I said, it's the census data. What is cross-sectional data? Next, moving on to the second type of data, cross-sectional data. It is data which is collected at a particular point of time, across subjects. What does it mean? When census data is collected, it is starting as a cross-sectional data. They need to go to each and every household, they collect the information, and then finally when we get from the website, it is consolidated and given to us. So census data is also started as a primary data, and we are getting it as secondary source. You know what is primary data? The researcher himself gets into the field for the first time to collect the data. That is primary data. And secondary data, you're sitting in your place and getting the data, like downloading it from the website, or someone already collected and in their research work and you're using it. Journals, any reports, all these are secondary data. So now we are speaking about cross-sectional data. That is, it is one or more variables you're collecting. As I said, census data. But at the same point of time, I'll give this example because for the students to keep it in mind. When you enter a doctor's clinic, on entering into a doctor's clinic, you can see a person sitting and taking a note or taking a record of your name, age, BP level, etc. So, if the doctor's clinic starts at 6 o'clock and closes at 8 o'clock, so 6 to 8, he's collecting data for across subjects for the same variables. At a particular point of time today, from 6 to 8, he's collecting data for around 50 or 56 patients. So that is the cross-sectional data. And pool data, I can say it is just a combination of time series and cross-section. So cross-section, if I want, I'm just writing here 2025 and today's date. You are having a data on gender, whether their age can be there, gender can be there, and their BP level something, or weight also. So all these informations you're taking at a particular point of time, it can be subject. So first person entering into the room, second person entering into the room, third person entering into the room, so on. When you speak about pool data, as we said, it is a combination of time series and cross-sectional data. So if I have data for India, okay, so for India, I'm having data, just I'll use only for 2022 to 23 or 24. Okay, 22, 23, 24. 3 years. For India, I'm having data. Okay, India. This is for India. India GDP. I'm having some figures here for 3 years. So this is time series data because it involves some time interval and equal time interval. So when I speak about pool data, for same year I'm having 2022. For China, I'm collecting for China, same GDP. 2023 is there, 2024 is there, same China. We have data for China, Japan, Bangladesh, few countries. The combination of that only is pool data. Panel data is a special type of pool data. We call this as pool data because we have countries across subjects. So time period is T. We denote time series data as T and cross-sectional data as I because across subject. And when I go to the model, I'll show you how we are doing it. So pool data is nothing but a combination of time series and cross-section. In pool, we can have balanced pool and unbalanced pool. Balanced pool means equal time periods. When time periods are equal, it is balanced. If time periods are unequal, it is unbalanced panel data. Then like certain initially they were okay, like when I was a researcher, we had limited softwares which uses we have only for balanced panel. But now there are many more the technology innovation. Then we get this, even we can work with the unbalanced panel data also. There was only one software then, Stata, which we used to do this unbalanced panel. But now we use even I think eViews is also having this. So we are comfortably we can get an output for this. When I finally conclude with AI, I'll merge everything and tell you how easy is it. Yes, but because since I want to have some hands-on practice for you, quickly, I just thought, okay, I'll speak about this correlation, regression and all. So correlation, it is nothing but the relation between two or more variables. If I have a variable like, I want to see, okay, how much your hard work reflects in your mark. So I'm just seeing the relation between your hard work and marks. So that is just taking two variables and checking the relationship. The degree of the, if I know, yes, there is a relationship between two variables. If I plot X and Y, it's very closely packed like this. Okay, closely packed, and it's moving up, meaning that it is positively moving, and it is the correlation is good. On seeing, that how closely the data points are packed. If the data points are loose, there is no relationship. It can be average, it can be zero, or it can be strong. So here there are a few graphs which shows you, and this correlation, what did I say initially with the graph we are seeing? If I want numbers, a numerical value to say what is the degree of relationship, 70%, 80%, 100%, or 40%. If I want to have a number, a solid number, which will give a better view, what is a better understanding. Anything with numbers, with numeric, will give you a good idea. In economics, everything we say, it is a when we have a monetary, what is it? What is it called? I just forgot. We have the consumer surplus or producer surplus. When we say, we just say the how much utility we are getting, or the more. When it is being given in numbers, then it gives a better idea. We actually put ourselves, or we think, yes, this number, meaning that I'm getting so much of utility because I consume this product. It differs from individual to individual. That is what we studied in theory also. So here, when I want to give a proper meaning, what I do is this is called as correlation, coefficient of correlation. It gives a number. Number lies between +1 to -1. When it is +1, means strong positive correlation between variables X and Y. It can be heavy rainfall and crop growth. When there's a heavy rainfall and good crop growth, then I say there is a strong positive correlation between X and Y. This is 90%. Yeah, see, it is fine. Here it is little scattered. 50%, okay. 50%, here there's a relationship between these two variables. It means zero. There is no relation between X and Y. No relation between rainfall and crop growth. If my study says rainfall in India and crop growth in Japan, it is ridiculous if I speak like that. But sometimes we get a positive relation with a good number for this data set also. That we call as spurious regression, spurious correlation. That is a new term. You can Google it. You can do a lot of research in that topic also. So this, next, moving on to negative relation. When there is a positive relation, means price and quantity supplied. Price increases, quantity supply also increases. Yes, the graph. And what is price and quantity demanded? There is an inverse relation. As price increases, quantity demanded decreases, So here there is a strong negative correlation between variable X and Y. So if it is 0, means no relation, plus means strong positive correlation, and minus means strong negative correlation. You can have many examples, price and sales. As I initially started with sales and advertisement expenditure, income and consumption, time spent on Facebook and your grade, time spent on your subject and your grade, study material and sleep also. There's a strong correlation, they say. And crop yield, that is what we said, no, heavy rainfall and crop yield. And when there are more variables, as given in the definition, between two or more variables. I should have included two or more variables. Not only one, only two variables. If I want to see the relation between rainfall, crop yield with rainfall, sunshine, fertilizer, quality of seed, quality of sand, temperature, everything. So that is multiple correlation. Quickly moving on to the next topic called as regression. Once I know if there is a relation between two variables, then I move on. This is also speaking about relation between two or more variables. But here you have a flow, which is cause and which is effect. It's very clear here. So it's the statistical relation between the variables when you fit in the regression model. When I get zero correlation or less than or greater than 5 is fine. If it's less than 5, if I run a regression with it, I won't get a satisfied or a statistically significant result. Expected result won't be there. So here, the variable on your left-hand side, we call this as dependent variable. This depends upon something. What did I say? Grade. My grade depends upon my study time. How much time I spent for study. How much time I spent on Facebook. See, there is another, or Insta. There is another thing also. I can spend positively in YouTube. I can study. That is also there. So to check the relation between the dependent and independent variable, we have this model. So here, if I have this YT and XT, what is T? T is time series data. Meaning that I have a time series data and I am doing a model with it. So here, dependent variable